Hey everyone, today we're going to look at Unit 5, Lesson 1, so solving quadratic equations by factoring. So we've already had a unit where we covered factoring. We're going to continue to use it. And then in our last unit, Unit 4, we were exploring what is a quadratic and kind of a lot of the key points in a quadratic. So we're going to continue exploring that in this unit and kind of move past what we did in the last unit and dig a little deeper with the content. So we're going to start with recalling from the last unit that when you're in factored form of a quadratic, you can figure out what the zeros are, right, by setting your brackets equal to 0. These are also called our x-intercepts or our roots. Okay, and we're going to give another name to those today. We also call these our solutions. So any of these words, they all mean the same thing. We're always trying to find our zeros, which are our x-intercepts, our roots, or our solutions. So we're going to look at this equation here, and we're going to think about, all right, if this equation is 0, or if y is 0, what will my x values have to be? Okay, so for the zeros, just to kind of refresh from last unit, for the zeros or x-intercepts, that means we're going to set y equal to 0 and then solve for x. Okay, so when it says solve here, solve the quadratic equation, it's meaning find the value that makes the left side equal the right side. Which again, we did lots of that with our linear as well. So that zero product property tells us that one of these brackets must equal 0 in order for them to be multiplied together and equal 0. So therefore our solutions or our zeros are going to be a positive 4, or we would add 3 and divide by 2. Okay, so those could be my solutions as well. Sometimes the equation will not have a second variable. It won't have a y. So we're just going to solve the following quadratic equation, not worrying about what y is, because they've essentially already plugged in a 0 there for us. So we have to look at what we have and determine how can I factor it to get it into factored form. So we're going to need to factor, right, because these are in standard form right now. So my first example, I have x squared minus 8x minus 20. So we have a simple trinomial. So we should be able to use SPF. I'll need two numbers that add to negative 8, but multiply to negative 20. Those two numbers would be a negative 10 and a positive 2. So remember, this is a simple trinomial. That's when we can set up our basic SPF. Okay, so if it's negative 10 and 2, we'll have x minus 10, x plus 2 equals 0. And then to find our solutions, we would set them equal to 0 and solve. So we had x equals 10 and x equals negative 2. We'll say therefore. Once again, these values, yes, we've called them our zeros in the past, but these are the solutions to the equation. Meaning if we plug them into the equation, they're going to make the left side equal the right side. Let's take a look at the next one. So we have 3a squared minus 15a. So we'll have to think about how we factor this. It's not a trinomial, so we shouldn't jump into SPF. We should do what we always should look for first, and that is a common factor. Okay, so I can common factor out here a 3a. If I take out a 3a, I'm going to be left with a minus 5 equals 0. And again, I can set both of those equal to 0 and solve. Okay, so 0 divided by 3 would just be 0, and we would add 5 to the other side. So just so that we continue to see These are our solutions. Right? I want us to get comfortable with recognizing that zeros are just solutions, because we're going to start calling them solutions as we move through this unit. Okay, the last one we're looking at, 25m squared minus 16. We don't have a trinomial. There's nothing we can common factor out, but we can take the square root of both of those. So we're going to factor by a difference of squares. So if we take the square root of 25 squared and the square root of 16, okay, square root of 25m is 5m, and the square root of 16 is 4. So when we factor that, we're going to get 5m plus 4, and we'll have 5m minus 4 equals 0. Okay, so if we set both of those brackets equal to 0, we can then solve for m. Okay, so I'm going to start by subtracting 4 for this equation, and then I'll divide both sides by 5. Okay, and you could do the same over to here. Add 4 and then divide by 5. This kind of looks like a y. All right, so once again, in this case, my solutions are a negative, or positive and a negative 4/5. And you can write it like that. When you have the same number, you can just put a positive and a minus next to them, and that will represent mathematically that you have two solutions. Okay, let's take a look at when we have an equation that might not be in standard form, we're going to need to rearrange it to get it into standard form and factor. So we're trying to rearrange it to standard form in order to get 0 on one side. Because remember, in that previous example, everything was set equal to 0, and then when we factored it, we could use that zero product property to set our brackets equal to 0. So I'm going to move everything to one side. So I have 2b squared and 7b on one side. I'm going to move that 15 over by subtracting it. And I'll have to look through and decide which type of factoring I'm going to use. But hopefully we can see this is a complex trinomial. So I'm still going to set up my SPF, but we're going to use decomposition after we SPF this. So we'll need two numbers that add to negative 7 and multiply to a negative 30, right? Because we'll have 2 times negative 15 is negative 30. That's where that negative 30 comes from. So two numbers that multiply to a negative 30 that add to a negative 7, that's going to be a negative 10 and a positive 3. So I'm going to decompose or break apart my middle term using those factors. So instead of a negative 7b, we're going to have a negative 10b plus 3b minus 15. Okay, and then I will factor from my first two terms and factor from my last two terms. So from my first two terms, I can take out a 2b, and I'll be left with b minus 5. From my second two terms, I can take out 3, and again, I'll be left with b minus 5. And then I will pull out that common bracket. So we have b minus 5, and then what's left over is 2b plus 3. So if we set those equal to 0 and solve, we should get that b equals 5. Okay, and if we set 2b plus 3 equal, we would subtract 3 and divide by 2. So those would be our solutions. Okay, I'm going to rearrange the next one, and then I'm going to get you guys to pause the video and see if you can work through finding the solutions. So I have x squared minus 7. I'm going to add x from the other side over to the left, and I'm going to subtract 5. So we get 0. And then I'm just going to write this in the order we're used to. So usually we have our x squared, then we have our x, and then we'll combine negative 7 minus 5 is a negative 12. Okay, take a minute, pause the video, and see if you can work through factoring and finding your solutions for this standard form quadratic. Okay, so you should have found that your solutions were at -4 and +3. The last thing we're going to do today, we're just going to take a look at a word problem, coming back to that idea of finding the solutions, whatever that solution might be looking for, determined by the context of the question. So a ball is thrown into the air. Its height in meters is modeled by the equation h equals -4t squared plus 12t, where t is measured in seconds. At what time does the ball have a height of 8 meters? Okay, so let's first do a rough sketch of what's happening here, as we do when we get a word problem. Okay, so we can see that usually where my y is, right, my h is now. So we're going to say, okay, my y is height. And where my x usually goes, I have a t for time. So I'm going to label my x-axis as time. All right, and then if we're looking at this, we have an equation in standard form. There's no c value, so that tells me my y-intercept is at 0. So the ball is thrown into the air at a height of 0. It's going to go up into the air, and then it's going to land somewhere. Okay? Really, the y-intercept is all we can tell at this point because we're in standard form. So it says, at what time does the ball have a height of 8? So it's asking us for the time, right? We don't know what the time is, but it tells us what the height equals. So we're basically going to need to solve for time. Our solution is going to be time in this case, given that my height equals 8. Okay, so I'm going to sub in 8 for my height and then try to solve. Okay, so just like the problems we had previously, we need to get everything on one side of the equation so that we're in standard form. So I'm going to subtract 8, so we'll have 0 on the left. And I'm actually just going to write my 0 on the other side. It doesn't matter where we end up deciding to put it, but we're just kind of used to seeing it over there. So we will write it over there. Now we have a quadratic, it's in standard form. We need to take a look at how we're going to factor it so we can find our solutions. So we should always look for a common factor first. And in this case, we can common factor, and we're going to pull out a -4. So if I pull out a -4, I'm going to be left with t squared minus 3t plus, not 3t squared, minus 3t plus 2. Okay, and then from there, we will continue to try to factor. So the trinomial I have remaining is a simple trinomial. So we're going to just factor a simple trinomial. So we do that by using our SPF, two numbers that add to -3, but multiply to a +2. It's going to be a -2 and a -1. Okay, so we'll have our -4 out front, and then we have t minus 2 and t minus 1. All of that still equals 0. Okay, so if we solved, we should get that t equals, not 0, t equals 2 and t equals 1, okay, when we try to solve those. So if we come back and look at our quadratic, it's basically asking us, okay, when my height is 8, right, what time does that happen at? Well, we just found that solution. If we follow that down, we could see that at 8 meters, the time is 1 second. And then if you follow it across, because there should be 2 points unless it's the vertex, it happens again at 2 seconds. So we'll just wrap up what's happening here with a therefore statement. So therefore, the ball will be at 8 meters high at t equals 1 second and t equals 2 seconds. Okay, so lots of kind of refresher from the last unit, but looking at our roots or looking at our zeros more as solutions to problems now. We're going to kind of continue with that theme throughout this unit. That's all for your note for today.